In the next example, you can see that we're asked to use gender, age, and years of experience to estimate the salary that is received by professors. If you look at the data, you can see that gender and age are qualitative variables, where experience is a quantitative variable. In all of the previous examples that we've done for regression, all of the predictor variables were quantitative. So now I'm going to show you how to conduct a multiple linear regression that includes qualitative predictor variables. The procedure for doing that is different depending on whether your qualitative variable consists of 2 categories or more than 2 categories. So you can see in our example, both of the qualitative variables consist of only 2 categories. So gender, male, female, age is over and under 40 years. So this example only explains how to deal with qualitative variables that consist of 2 groups. In the next example, tab 4, I'll show you how to use qualitative variables in a multiple regression analysis that consist of more than 2 categories. So if you have a qualitative variable that only consists of 2 categories, you're going to use binary encoding. So what we're going to do is we are going to code all the professors that are male as 1 and female as 0. So I'm going to use an if statement. So if the gender equals male, then they should receive a 1, if not, a 0. Then I'm going to copy this function down. Moving on to age, I'm going to use an if statement. So if age equals under, then they should be coded as a 1, if not a 0. And then I can copy this formula down. Once you have transformed your qualitative data to numerical labels, you can conduct the analysis. So I'm going to open the data analysis toolpack. I'm going to select regression and hit OK. My Y variable is salary, and my X variables would be my predictor variables, and that would be gender, age, and years of experience. I'm going to check labels, and then for output range, I am going to click on the designated cell. First, we will conduct the global test. If you look at the p-value for the global test, you can see that it is less than 0.05. Again, whenever you see that E negative a number, that's a really small value, and it automatically means that it's significant, so it's less than 0.05. So that means at least one of the predictor variables significantly predicts salary. So now we can move on to the test for the individual coefficients. You can see that gender is significant. The p-value is less than 0.05, so that is significant. I'm going to highlight that for green, that it's significant. The p-value for age is 0.356, so this would be non-significant. So this is greater than 0.05, so that means that age does not significantly predict salary. So that is non-significant. The p-value for experience, again, it's a very small number. It has that E negative 0.07, so that means that it is significant. It's less than 0.05. So experience significantly predicts salary. In the instructions, we were instructed to use the all-at-once method. So the all-at-once method means that for the second analysis, you exclude all non-significant variables. So we're going to conduct a second regression analysis, and we're going to exclude age. So we're just going to use gender and experience to estimate salary. So if you move back to the data, you can see that we want to use gender and experience to predict salary. However, you can see that the two predictor variables, they're not next to each other, and that is going to pose a problem. So what we have to do is we have to rearrange the data set in order to conduct the regression analysis. Anytime you do that in this class, what you're going to want to do is you're going to want to copy the data set, and then you're going to want to paste it to the right of the gray bar. So I'm going to paste it right here. And now what we can do is we can remove age.
So now gender and experience, our two predictor variables, are next to each other. That way, when we conduct the analysis, we can highlight both the data for the two predictor variables. In this class, anytime you need to rearrange the data set or delete columns, you're going to want to copy and paste the data set to the right and then do so. Again, you never want to delete any columns or rows in your Excel file. However, you can do that to the right of the gray bar.
I'm going to open up my data analysis toolbar. And the Y range is salary. And my X variables, my predictor variables, are gender and experience. And then the output range is going to change, and I'm going to place my output right here. So again, we need to start with the global test. You can see that the p-value is less than 0.05, so it is significant. It means that at least one of the predictor variables significantly predicts salary. So now we can move on to the test for the individual coefficients. If you look at gender, you can see that the p-value is very small. It's less than 0.05, so that means gender is significant. It significantly predicts salary. For experience, the p-value is also very small, so experience significantly predicts salary. So these two variables are both significant.
Now I'm going to complete the model summary table. I'm going to do so by referencing the cells in the output. So the y-intercept is 39.43. The slope for gender is 13.89. Age was not in the final model, so I'm going to write NA for both the slope and the p-value. The slope for experience was 1.24. And again, you always want to reference the final model. And the p-value for both gender and experience was they were very small numbers, so they were less than 0.001. Again, anytime a p-value is less than 0.001, you can just type in less than 0.001. And then finally, we want to reference the standard error. So our standard error is 9.13. Now I want to talk about what the interpretation of the y-intercept and the slope for gender is. If you remember, the y-intercept tells us the predicted value of y when all of the predictor variables have a value of 0. Gender was binary encoded, so 0 represents female. Our other predictor variable, experience, that was a quantitative variable, so a value of 0 would be 0 years of experience. Our y-intercept was 39.43, or 39,433. So this means that a female, that would be a value of 0 for gender, who has 0 years of experience is predicted to have a salary of $39,433. The slope for experience was 1.240. So that means for every additional year of experience, salary is predicted to increase by 1,240. So again, the slope tells us the predicted change in y if x increases by 1 unit. So for every additional increase of 1 year in experience, salary is predicted to increase because our slope is positive. However, the slope for a qualitative predictor variable gets a little bit trickier to interpret. So our slope was 13.886, or $13,886. So again, the slope tells us the predicted change in y if x increases by 1 unit. So if you remember, gender was coded as 0 is female and 1 is male. So if x increases by 1 unit, that means that we're going from a female to a male. So males, in comparison to females, are predicted to have an increase or a higher salary of about $13,886. So now we can answer our questions. Question number 1 asks, based on your regression analysis, what is the final conclusion regarding gender? And the correct answer would be A. Males are associated with increases in salary. For question 2, it's regarding age, and if you remember, age was non-significant, so C would be the correct answer. Finally, what is our conclusion regarding experience? That would be A as well, so increases in experience is associated with increases in salary. The last thing I'm going to do is complete the prediction table. So we want to predict or estimate salary for these individuals. In order to do that, first we have to numerically encode our qualitative variables. So I'm going to use an if statement. I'm going to use binary encoding. So if the gender equals male, then they should be coded as a 1, if not a 0. If age equals under, then they should receive a 1, if not a 0. Right. So now we can utilize the regression equation to estimate salary. So it would be equals the y-intercept, locked, plus, and then it would be the slope for gender, locked, times gender, and parentheses, plus, and then in parentheses, the slope for experience, locked, times the number of years of experience. And then we can copy this formula down. And now for the 95% prediction interval. So the lower limit would be y hat, or estimated salary, minus 2 times the standard error. And the standard error needs to be locked. The upper limit is estimated salary plus 2 times the standard error. And don't forget to lock the standard error. So you can see for the first individual, they were predicted to have a salary of about $54,000, and we are 95% confident that their true salary will be between about $36,000 and $72,000. In the next video, I'm going to show you how to conduct a multiple regression analysis with qualitative variables that have more than 2 categories.